All right, so we are talking about polyesters today, but before I dive into polyesters, I want to talk about what polymers are. Oh, no, I can't spell today. Polymers. So the first thing we have to think about with polymers is that all they are is just a repeating long unit chain. So it's a chain of repeating units. Sorry, I don't know why it's not focusing today. Why are you having a fit today? Focus on my hand then. There we go. Okay. So polymers are a chain of repeating units. And it's a really, really long chain, like hundreds, if not thousands of like things long. The way I like to think about it is you have like individual gentlemen. All right. The way I like to think about it is you have individual beads. So these are the repeating units, and then we've tied them all together, making my polymer. Wow, my document camera is not happy today. Maybe I should move it. See if it likes it better like that. All right. So different polymers are going to have different types of characteristics depending on what these little repeating bits are. An example of a common polymer that you guys deal with every day and that we would have talked about last year in structure and bonding is plastics. So plastics are an example of a polymer. It's a nice repeating unit. Depending on what we have that makes up that polymer, we can get lots of different varieties of plastics. You can get really hard plastics like my little rubbish container here that doesn't bend, or you can get really soft plastic like on my watch to then go around my wrist. So depending on what I have making up my polymer, that's going to influence what I get. These can be both artificial and natural. So natural ones would be examples like fibers, like plant fibers would be my kind of big example of that. So polymers are quite common and very useful to us. There are two ways we can make polymers. Or actually there's more than two ways, but the two ways you guys are concerned about for organic chemistry is as follows. The first one is we take alkenes, so like C double bond C, and what we want to do when we make this polymer, so I'm just going to draw another one to start as my example as a polymer chain. So the first way I can make my polymer is I break my double bond like that, and then I link my two alkenes together. That is an example of an addition polymerization. So the double bond. So we break the double bond and we add the alkenes together, basically forming a chain that is alkane-like, as an example. Okay, we can represent it as like dot, dot, dot to show that it continues. We call this form of polymerization addition polymerization. Breaking double bonds, adding them together. And I'll leave it there for now. because I know you guys are still writing notes. Just let me know when you're ready. Zoom out. It's behaving itself now. All right, ready? Next bit of information. All right. The second type of polymerization is called condensation polymerization. Where have you guys heard the word condensation before? Condensing, which is referring to like turning into a liquid. What common liquid do we think about? Water. So a condensation polymerization, it works by removing an OH from one molecule, a hydrogen from another molecule to join them together, and then water is the byproduct. So condensation polymerization removes an OH from one, what's the word for these guys when they're by themselves? Monomer. And a H from another. So we're removing one hydrogen and one OH from each monomer. So there's two monomers that we're putting together. What this means is that we have water, H2O, as a byproduct. Hi. What do you need? Yes, they are. Yes. Yeah. Charlie, Sabrina, you've been summoned. You don't want Mena? Okay. Charlie, go. All right, keep going. Not yet? Okay. All right, keep going now. Keep going. Okay, Matthew, ready? Okay. So there are two that you guys are going to be learning about with the condensation polymerization. The first one is going to be polyesters. And then the second one's going to be polyamides. Now there's a nice little hint then on how these guys are going to join together. These guys join together and form an ester. These guys join together and form an amide. So those are two main ones we're going to learn about. The other thing to keep in mind is that with the polyesters, it goes into another kind of subcategory that can come up as an exam question, and that is the triglycerides. We won't do the triglycerides today. We won't do the polyamides today. That's going to be all next week. I'm just focusing on the polyesters first. So just be mindful to see how everything kind of fits together. All right. There are two ways I can make a polyester. The first way is I have only one monomer with a alcohol and a carboxylic acid functional groups. The second way I have a polyester is I have two monomers. I have one that is a diol and one that is a dicarboxylic acid. So this one we have two monomers. And I just want to point that out to you guys because the exam question I'm going to show you today has both versions, so you guys can get used to seeing them both ways. The polyamides, exact same kind of setup as the polyesters, just we swap out the carboxylic acid group for an amine group. So we have option number one, you have one monomer with an OH and an amine. Or option number two is we have a diol and a diamine. So that's two monomers when we make those guys up. I should also add they often use the polyamides for the protein question, which we'll cover later. Yeah, which ties into your biology. You'll see what I mean when we do it. So this question here touches on a lot of different topics, which is very useful. So it's going to actually benefit you in multiple questions on the organic exam. The other thing to keep in mind with the year 13 organic chemistry versus year 12 organic chemistry is that the question is basically going to be on the condensation polymerization. It is very unlikely they will ask you about the addition polymerization. So we're going to be focusing on condensation. Unlikely they will ask the addition polymerization. Very unlikely. I haven't seen it. And when I did see it, it was in an expired exam. So not something we currently assess anymore. All right, questions, concerns, comments so far about this? We're good? All right, I'm going to pass out an exam question so you guys can see how they ask this question. All right. I'm taking these from two different exams, just FYI, so you're not worried. Okay. So the first one is from the 2018 exam. In this example here, we are trying to make a polymer, that's a polyester, also known as polyglycolic acid, and it's made using glycolic acid. Don't worry about all these namings because a lot of these are just kind of like common names and not proper scientific names. You guys obviously will name it differently if it was scientific, but this is just our day-to-day kind of one. This is used to make dissolvable stitches, and they've given you the structure of the glycolic acid, and they want you to draw a polymer of this glycolic acid, and they want you to show 3 repeating units. So basically, you are drawing this 3 times. So let me show you guys how you're going to put that together, okay? All right. So first thing is I know the OH and the hydrogens are going to get removed. So when I start drawing it, I'm going to exclude them so I can start linking them together. So instead of starting from the OH, I'm starting from the carbon. I see that that carbon has 2 hydrogens. I'm going to do a little squiggle line like this to indicate that I know it's a repeat polymer. And then I'm going to do the second one here, which is C double bond O. So this is going to lose the OH, that's going to lose the hydrogen. And then I draw an O to represent the other one there. And then I do my link and I start my next monomer. So basically I just draw this guy over again. C, H, H, C, double bond O, single bond O. How many repeats do I have right now? Just 2. Draw one more. C, H, H, C, double bond O, and then that's my end bit. I'm just going to use a little squiggle line. You can use dots. The other thing you can use if you want is square brackets on the ends and just doing an N, just to say a repeated structure. All of those would be deemed acceptable. We're just trying to show that this isn't like the ends of the units. Do you guys see where the ester is for this polyester? So it's that component here. That's where it is. So the ester is linking it together. And actually, I should say it's the OH coming off of this guy and the hydrogen coming off of this guy. So actually, this oxygen's coming from this guy. Should have made that a little bit clearer. Does that help? I'll do it like that, so that way it's kind of clearer. We good? All right. So explanation for this type of reaction, this is a condensation polymerization. The reason being I am removing water. So we're taking an H from the OH and an OH from the carboxylic acid, and that together is forming H2O. And then when we link it together, we form an ester. Questions, concerns, comments? The explanation of what you're doing is written here. So we're removing we're removing an H from the alcohol section and removing an OH from the carboxylic section. By doing that, I can then link these guys together in the form of an ester. Thus the name polyester. Now, unfortunately, NZQA doesn't have the marking schedule up for some of their exams. I have to find out what's going on. My guess is that this question would probably be a merit point. I'd be very surprised if that was an excellence point. All right, keep going. All right, so that's one thing. So we're going from monomers to polymers, and we need to also go backwards. Polymer back to the monomers. We got to break it apart. So the 2021 exam, question number 3 is an example of working backwards. So they have given me an example of polyethylene terpentine, I can't say that, PET, very common polymer used for making fibers, film, and packaging. They've given us a section of it, and they've given us 2 repeating units. So we have I think that's a benzene in the center, We have our carbons, a double bonded O. We have this guy here, then we have that guy, and then we have that guy. So 2 repeated sections. It's a little bit longer, and I can tell by looking at it already, I have 2 monomers. And I'll show you what I mean when I break it apart. First thing I want you to do is circle one of the esters as a function group. So to do that, just gotta look at the guy, see where my carbonyl is, see where that single bonded oxygen is, and here is my ester. There are, in fact, a couple of esters there. That's an ester, that's an ester, and that's an ester. Any one of those 3 is fine. Are we okay with that so far? Okay. Next thing they're asking us is to break it apart, and they're going to ask us to break it apart in both acidic and basic conditions. That is a really important thing to remember because it means that we have to distinguish what's going to happen to the carboxylic acid in the various solutions. This is a hydrolysis reaction. So hydro, what does that mean? Water, lysis. Lysis. You might have heard in biology, like cell lysis. No? To break apart. So hydrolysis. What would I be doing then? Breaking it apart with water. All right. So I'm breaking it apart with water. So in the previous example, we saw that we made it by removing water from our molecules and we can link it together. What I'm going to do now to break it apart is the opposite. I'm going to take the water and I'm going to add it back into my molecule to break it. All right, so let's see what these 2 look like. So when we're looking at this molecule right here, we want to find the 2 monomers that we are dealing with. So I have one monomer right here. If you guys can see it. Actually, I should have probably drew it like that because you're not going to take the oxygen there. We'll do it like that. Sorry, guys. I'm making a lot of mistakes today. All right. And then the second monomer that we have is this guy over here. You see it? How it repeats? All right. So when I break this first guy off, actually, this one's a better example. You see how you have your little benzene in the center? That's what a benzene is. So all that's telling you is that you have a carbon, double bonded, carbon, single bond, carbon, double bond, carbon, single bond. It just is that guy. If I was to draw it out bigger, that's what that is. So we're just translating that across. You've seen it before. It's just a ring. It's a ring with some double bonds. All right, so that guy's in my center, and I see it has 2 carbons coming off of it. The carbon has a double bonded oxygen, and since this is an ester, I am making this by having a carboxylic acid. So if I was to add my carboxylic acid, I'd be adding my OH backs. Are you okay with how I got that? So like this guy up here, that was a carboxylic acid. I split that guy up. The other thing I have then, what's up? Yeah, do you want me to pause it? Because there's something that Miss needed me to talk to you guys about. I know she talked to you guys about it yesterday, but the more we can reiterate, the better. It was the STEM course. Let me just find it. Actually, I emailed it out. Let me find the email. So, Faya Katarina was the one that put us onto this, and it's a really great opportunity for Madi and Pacific students. I just need to find it. There it is. Here we go. don't like, I want to go back to Chrome. Give me Chrome. Chrome is the one that everyone uses. Chrome is the one what? Okay. So you guys qualify for this, and I want to point it out to you guys. There is something called the Discovery Camp, and it is a camp designed to help support Māori and Pacific students going into these sciences or anything STEM related. So science, technology, engineering, or medicine. Math. Math. But if you're going into medicine, this would also apply for you. I know Vaitohi did something similar last summer at Auckland Uni. So this would be kind of, I would assume, similar level. But this one is designed for Pacifica and Māori students, whereas the other one you went to was just for everybody. This one is down at Victoria University in Wellington. Really great opportunity to see another university and see how you like it. It is also completely free. And when I say completely free, it's not just the camp itself. It is flight, accommodation, meals, activities. It is all paid for. Right? Unfortunately, Glenn, you don't qualify because you're not Māori or Pacifica. So just the Māori and Pacifica students. I'm sorry for all the Filipinos that are in here that are not qualifying. All right. You are applying for this. I will link this onto your Google Classroom page. The thing that you guys have to remember is this application closes on Sunday. I only just found out about it this weekend. So you need to get in gear to apply if you want to go. All right, I'll put it on. I'm happy if you guys want to spend this time now to apply. I think with the application, so it's stuff about your details, your ethnic group, tribes and stuff. And then I think they ask for references as well. So you will need contact details for a nominated parent or guardian. You will need contact details of a nominated referee teacher. I am happy to be your referee teacher. Your school address, a copy of your formal NCA results, and your statement of motivation. I am happy to read your statements of motivation before you apply so it doesn't sound like, so it sounds great, okay? All right? I'm happy if you want to use this time now to do this, okay? Sunday is the deadline for this. I will link it on Google Classroom. So it doesn't state number. I'm guessing since they're asking for your academic records and a statement and references, they will be comparing you against other students. So they will be looking at all the applications and they'll be picking you guys out. It's not a matter of you apply and you get it automatically. It's like a scholarship. Okay? So write some good things. I'll link it on our Google Classroom page, and I'll put it on the science one as well. Yeah, so I think it's a week, and it's free. So the 22nd to the 26th, so it's a week. I'll post it to the science page as well, so fill it out. It would be a great opportunity. It's for year 12s and year 13s. So, anyway, I'll put that on then as your Mahi choice. All right. All right, there you go. Time's yours. Got 25 minutes to get work done. I think that's everyone. Let's see. Neil, Mena, who else is in that? Michelle, Brooklyn. Yeah, cool. And then Jess, oh, totally. Cool. All right. Take some to work on. It might also benefit to actually put Ms. Sola down as a reference as well. I think you're only allowed one, but she's Pacifica, so it might be good to have another specific person as your reference. So, but either Ms. Volatile or I would be good, or Ms. Brooker if you're in physics. Whoever you think. We'll say very nice things about them.
Ja, just you.
Yeah. You guys are. I'm glad you have some second about it. Emma did the same one that I did as well. I know how great it is.
Well, let's try.
Well, access Sunday to apply, check your family. Is see if they're like, and the thing is, there's no harm in putting in an application. I mean, you're not guaranteed to get it. Good stuff. There. And I think they would understand if you missed the family. Sending the email you got from the phone. So, I just double, but I just want to make sure. And do you have, like, what the reason behind it is? Either or, on person. Using your personal email that your school wants, just in case they deactivate it when you guys graduate, they probably will. Make sure your personal sound professional, not like, I don't know what's a good example. Volleyball girl. That's just like, yeah. Did I put Ms. Paul's details up there too? Just make sure Ms. Falso knows if you put her down as a reference. I'll put myself up there. So you can choose. I'm not to be offended. I just thinking application wise, it could be beneficial if you put Ms. Falso down because she's also Pacifica. So her reference can be from the Pacifica lens. Whichever works though. No, you don't, you take that. All right. That's the phone number. All right, I'll put Miss Souls down as well. All right, if you're putting down this solo, here's hers. There you go. Are we something if we do yeah. Yeah, I remember something. That's a joke name. Carrie Technology. Or you try Carrie Bot, it'd be fine. I just like to emphasize that I have a middle name. Remember with your personal statement that they're asking for to spell check and grammar check. Yes. And talk about your hopes and dreams, what you want to accomplish, what will you do with the knowledge you gain in this program. Okay. Oh, so that was in the game by Polymer. Yeah. Something like that. Because it's more of the same thing instead. Yeah. Instead of being higher. Good t-shirt. And then before we talk about like acid base and this is blood and base and all. Okay.
Wait, what is the difference?
Yeah. You can use other teachers as well as asking me or science teacher. I'm guessing you've downloaded them off of Kindle? I can ask. I'll ask you guys. Because you should be able to download the record of the chief. If not, I'll email this meeting as well. See how. Records. Application will be sent to you back. Actually, I'll go ask Miss Brooker first. See if she knows. I'm gonna ask Miss Brooker. Like if they offer you a scholarship, that would be your app. Scan it. And save the file. Because you can scan it and then have the printers or the thumb up here and send it to yourself. There's also an app you can download on your phone called Hand Scanner, and that can scan documents for you. Hand Scanner. So I'll have to ask you guys how to get the answer record. Yeah. Yeah. Okay. Where is it? Okay, so you log in here. Where's that? So select documents, academic details. Academic details. New documents. Then you take the Dagger University Center. You take the University Center. Oh, I help you. It's all my mom. That's all. They do their job. Then I'll win it. All of them do the job. That's right. Are you flying for hours? Yeah, probably is a better place to go. You should probably, there's probably a way to recover the password and stuff. Maybe it's a here thing. Yeah, that makes sense. Okay. Let's figure that out. There's my website. Yes. I think it might be the QA website where you get your transcript. That's fine. This is for Octava. But you're talking about the school. Yeah. What do you want? Should we help you?
Yes. That's what you need to. You need to like you need to oh.
Are you okay?
Why did it say 6 and rising?
I need to.
No, they all press.
Wow, wait, what? I'll go to the next.
So like, it's definitely a lot. Procedures are on muscle. Yeah, I know that. Yeah, so like we use that as part of like just ask, no harm in asking. And also if you say that you're from like financial hardship, blah blah blah, give you some more ideas. Not that happens. Stop, sorry. I like the heart. How many? Like it's like
If you watch this.
one second was that. And right. We do these applications. Secondly, we're going to solve one. Also be mindful that everyone's fine. So, again, anything that you guys would really want to highlight is like, what are you going to be, like, I don't know, for me, my best looking at applications and stuff, like seeing how you're doing it. So they've given you the SWOT practice. How are you then going to like help? Genuine. If it's something you're not ready to talk about your practice, but why? Maybe that's why they don't require you. Yeah, it's not in the. They want to look at, if you want me to look at statements, yeah. Yes, there's minus two. Oh, give me super thanks for. It also shows no soul. Like I don't see anything that says no. Yeah, it's not like you're on this. Because you started doing it, you started to share, you want to, but forensic scientists say it was a role. So like, why do you like yourself? Why do you want to? If you see a lot of injustice, how to see that they have to think like you're competing against someone else's apply and you wonder how the application to stand out. The way you make your application stand out is going to be so. Treat it more like English writing. I want you to give it a nice letter. There are two of my is that now have more also the first minute. They have to what's left. So when you can't have more, but the this was a full. Right, well, I'll see you next quizzes. They're coming up, but so you know, great quiz. You just want me to post it on Google Classroom? That'd be easier. I'll do that. Actually, I have little. Hold on. There we go. Easier. Anybody else? Oh, cool. I'll mark it. Gotcha. Okay. You know how nice it would be if Miss Solo walked in and saw you guys weren't on your phones? I think she'd really like that. Your teacher, when she. Okay, well, just saying. She would probably appreciate that.